Hi everyone, I'm Mamy Ratsimbazafy. I'm a Ethereum 2 and Nimbus developer at Status, and today I want to talk to you about using Nim in production. So Nim is a very young language compared to many other languages, and very few people know about it, but some companies now are more and more interested in Nim, but are afraid of taking a leap of faith and starting to use Nim more in production. So I want to address those issues and give them some ideas on how to tackle and manage risk. This talk is also subtitled "With great power comes great responsibility." Why? Because Nim gives you a lot of freedom, and when you work in a team, those freedom might lead to friction between developers, coding style. So I want also to give you some links to that we used at Status, where we have over 20 people using Nim, so that you can handle that in a nice and graceful way. So let's talk about Status. Status is the main sponsor at the moment of the Nim programming language. We've been sponsoring Nim for a couple of years now. And what we do is, our main product is a messenger based on blockchain. And it's all open source, all decentralized, peer-to-peer, transparent. I mean, even our meetings are recorded on YouTube, and we talk about our own financial on YouTube. So this is really a core point of our philosophy. And we are, besides the product, we also develop core infrastructure, peer-to-peer infrastructure. So messaging, consensus. Consensus means blockchain, basically. We're based on Ethereum. And recently we are also tackling storage. So not only like BitTorrent decentralized distributed storage, but also making sure that over the long term, there are some incentives besides just reputation to make sure that something stay available for a long time. And this would be used, for example, for messages to store memes or messages for a long time. Okay, so why what I will be talking about is relevant to you? We are over, as I said, we are over 20 developers using Nim at Status. Some were original gangsta of Nim. Most of them are working on the blockchain, Ethereum blockchain client, but others came from C, C++, or Go. The transition to Nim was easy. So in terms of teams, we have Ethereum 1 team. That's all everyone started, but then most people migrated to Ethereum 2, where we are over 10, and Ethereum 1 now is 3 people. Lippy2P is a peer-to-peer network stack that is used by all blockchains, and Nim is one of the official implementation, and we got sponsoring for that. Waku is a messaging protocol, so this is a fork and a re-implementation of something that was started in Go, and this is something that is like the reference implementation is in Nim, and we are also writing other implementation in JavaScript and Go, but Nim is the reference one. And then we have also a team called Status Desktop. So this is a desktop client. That client used to be in what was it? React Native plus Qt plus Go. And now it's Nim plus Qt plus QML. So that's who uses Nim at Status. And in terms of stakes, and to give you a bit more idea of what kind of industry we're working with, the blockchain and cryptocurrency industry is really related to peer-to-peer networking. That's our main, let's say, differentiator and our main skills. This means that everything that has to do with async or networking are really core to us, and we really need to have full control end-to-end of the code. Both in terms of velocity of deployment and also in terms of audits and documentation and API. Also, cryptography is one of the core parts, but in that case, we can use C libraries, and we actually should use C libraries. We have also databases to store state of the blockchain, and we do use a lot of caches. So because to accelerate retrieval speed of various information. One thing is that blockchain is moving fast. First, this joke from Interstellar where you say, this little maneuver will take us 51 years. And blockchain is really like that. 6 months is a long time. For example, we released our main blockchain Ethereum 2 client 6 months ago on December 1st. Now, our client is securing a network of over 12 billion US dollars as of June 19. And this was like way bigger when crypto was higher, but we are a very high-profile hacking target. What does it mean also? In terms of media reach, Nimbus is starting to get well known on crypto Twitter and crypto Reddit. And this means that more people are getting interested in the NIM programming language, and in particular because our focus is on Raspberry Pi, resource-restricted devices. We do great in terms of memory usage, and we are a single-threaded client, and we can still follow the high performance requirements of a blockchain, because we have, like, when I say high performance requirement, it's in particular due to networking and very state-of-the-art cryptography that takes milliseconds, and we need to gather a lot of messages going around on the peer-to-peer network. Another thing is that crypto is all open source, all community-led, and there is a high demand for documentation. People are asking us about APIs, about blog posts, what are we doing, and very like openness, and this is really valued. And similarly, there is a high demand of audits because there are so many scams and hacks going on. Code needs to be audited in crypto. And we spend a lot of time and a lot of energy and also money to make sure that code is audited. And our own code was audited by 3 different firms focusing on different areas to make sure that we deliver a baseline implementation and quality. And also, so in the same vein, there is a great need of reproducible builds, because some people just don't trust what is given to them, and they take the code and recompile it from scratch on their own machine. And this means that we are stressing the build system and all the dependency management. So if you recognize yourself into one of those things, at least I hope the talk will be helpful to you. Let's start with hiring. So because without NIM engineers, you won't go anywhere. So even if you don't have any NIM engineers right now, maybe you have one, maybe you have two, and they are pushing for it. Anyone that worked in C, C++, Go, Rust will have an easy transition into NIM. If they start from C, C++, Rust, NIM also offers manual memory management capabilities, but the garbage collector will, like, for everything where performance or manual control isn't critical, the garbage collector will be a lifesaver. And for Go developers, well, if you have a networking application, for example, I mean, you can just use NIM just like you used Go. The transition is quite easy. And for a domain expert, like we had domain expert coming that were specialized in peer-to-peer protocol, and they re-implemented in just a month something that they did in Go in the past. And actually learning a domain like peer-to-peer networking or blockchain takes much longer than learning NIM, and both can be learned at the same time. We saw that with juniors that started from other languages and eased into NIM in a couple of weeks. One thing to note is that you need at least one NIM mentor, so someone who's familiar with the ecosystem and also follows the bug reports and the RFCs in the main repos, because there are a lot of hidden knowledge about bugs, workarounds, and what's going on. So I recommend having one NIM mentor. And one of the advantage of choosing NIM is people that actually are interested in working in NIM are really driven and passionate about code, and they care a lot about code quality. Also, they would develop on their own free time. So it's a mindset, and maybe it's one of the hardest thing to acquire as an engineer. So if you start with someone with that mindset, that's one less thing to worry about. Like you get great code quality, and you get people passionate about something, and maybe even vocal and willing to talk in conferences about your product and how great what you're doing is. So besides that, NIM has a lot of advantages that we felt were why it was the right fit for us as a Nimbus team. So even though the NIM standard library is really, really small compared to other languages like Go or Python, you can reuse any C library easily because NIM compiles to C or NIM compiles to C++, and generation of bindings, especially C1, can be automated by C2NIM or NimTerop, and just in a day normally, you should be able to create bindings in NIM. So another thing is I touched upon a bit speed and memory usage. Rather than tell it myself, let's have a user tell it. So this is from someone who is using our product, so a blockchain client on a Raspberry Pi, and he said, after having done lots of testing on my Raspberry Pi, I can confidently say that Nimbus has given me the best results. It's designed specifically for low-power systems like this. It uses the least amount of RAM by far, about 700 to 800 megabytes. So this amount of RAM might be high for regular application, but for blockchain clients, this is actually quite small because it includes caches, it includes history for the past months of transaction, and complex logic for networking and blockchain consensus. So it's when you say by far, it's really by far. Another thing that is great about NIM is Python is currently the language of research, and this is true for blockchain, this is true for machine learning, this is true for science, maybe physics or I don't know, statistics, psychology. You start using Python now instead of, say, MATLAB. And this means that researchers, they can reread the code of engineers, and you can compare and make sure that you are actually implementing what you need to. And in our case, this is also a key advantage for auditors. They spend much less time on code when it's basically copy-pasted from the research. For the small story, we actually kickstarted our Nimbus if1 client by having a Python to Nim translator, and then starting removing things that we didn't want or wasn't useful in Nim. For example, the type system removes a whole lot of if-is instance of from the code base. Now, we talked about the advantages. Let's talk about how to deal with immature ecosystem. So on the left, you have things that we had to work around from, and on the right, our workaround. So the standard library of Nim, it takes a battery-included approach inspired by Python, but it's immature, and in our case, there are many things that were either a bit clunky in terms of API, or we needed to control end-to-end because of, let's say, security concerns. For example, a bitops module for bit manipulation. And what we resorted to is just like Google or Facebook with their standard library, internal standard library called Upsell and Foley. We forked it. So we have bitops 2, Endians 2, and this avoid burdening the Nim core team with our own updates. This decouples your product schedule with Nim schedule, and the community can re-import the changes you do, or consider them for maybe a V2 of the standard library. So similarly for compiler updates, the compiler can still break things from one major version to the other. We saw that, for example, with things like shift right or I don't remember. Well, we had a couple of updates that broke our workflow. Sometimes it's generic changes. So it's important to pin to a compiler version and pay the debt and upgrade it when you're ready for it. And you can dedicate a week of testing and making sure that the new compiler is works well with your code base. And so another thing is that Nimble, the package manager, has no log files or monorepo. And for our needs, like, we really needed to have reproducible builds and making sure that all devs were developing on the same version of all libraries. So our workaround was using submodules and makefiles. We are also sponsoring an effort to add those capabilities to Nimble. Hopefully that gets developed in 2021 or 2022, but in the meantime, makefiles plus submodules are an okay alternative. The last point is third-party packages. So at Status, we had the budget and the incentives due to security and to write a lot of packages ourselves, but we still use some third-party packages like YAML, for example. And we had cases where even if we pinned a dependency, sometimes it disappeared because there was a rebase, I think. So in that case, I recommend you clone and pin the clone to avoid that. So really, the message is that while the ecosystem is immature, you have easy C and C++ integration that can give you everything you need from C and C++, and there are workarounds for the tooling, and there are efforts to improve it on the way. Now, I've talked a lot about safety and security. This is a key point for us at Status. We wrote something for security auditors called the Auditor's Handbook. The link is a nimbus.guide auditor's book. If people are worried about, well, is NIM as secure as C++, as secure as Rust, as secure as Ada, or maybe over Zig or other languages, direct them to this auditor's book, and it goes over what NIM offers and what NIM will offer. It might be a bit outdated. It was written in July 2020, but it should give you a good background and an idea of the mindset of the NIM developers. We also have a style guide, so this is more geared at how to work in a team, how to choose a subset of NIM that is robust enough, that has been tested both in the standard library and at Status, and that we are sure work well, because there are features in NIM that are on paper great. So we saw that with distinct types that were used, for example, for tainted string, to make sure that string coming from network or read from file are validated. But the implementation was actually there were some ergonomic issues that made the feature less appealing to use. And there are others, like ranges, using the natural type to make sure that something is always positive, for example, that we cannot use at Status, even though it would be ideal, but we cannot use because there are some issues in symbol resolution that makes it not ergonomic enough to use. So I want to highlight, because this is maybe things we've been bike shedding for over 3 years. Exceptions, result types, options, and enforcing checked exceptions with push raises. In an async world, the issue is that exceptions are really hard to handle when they are re-raised from the async framework. So we really you really need to use result type and options wherever you use async. Otherwise, just use whatever is more convenient for you. And for exceptions, we are using everywhere something called push raises, and this enforces all exceptions to be caught and handled in the module. So this was a kind of breakthrough, I think, to improve the reliability of a product and reduce the number of Eisen bugs and hard to debug conditions when they are weaved into peer-to-peer messaging with hundreds of peers. I've talked about the safe subsets of NIM. It's detailed in the NIM style guide. And one thing that is really important or really nice about NIM is that everything that can be used for C or C++, so fuzzers like libfuzzer or American fuzzy loop, and sanitizers, so the address sanitizers and thread sanitizers from Clang LLVM and GCC can be used with NIM, so use them. So very important point, developing in async teams versus developing as individuals. we have teams at Status. Many Nim developers work as individuals, so this means that everything they use is only for them. In our case, we need to make sure that the whole team is on board and can understand whatever people are doing, and don't like clash. We don't have clashes in updates. So it's important to have automation and have some kind of environment script because we use make files and submodules. We have a starter script to make sure that we have a custom shell for developing and everyone is on board and has the same environment variables, same version of Nim, same version of all dependencies. And of course CI for all platforms. We have people using Windows, Linux, Mac, that's fine. And with CI we can make sure that everything works. For branches, we have something, so a stable branch where everything that we release to the world goes. We have unstable, where people make PR against the unstable branch, and once every week or 2 weeks we put unstable onto testing. Testing is deployed onto our fleet to make sure that what we want to release as stable was tested for a couple of weeks. And so to remind you, pinning dependencies as a compiler is key when you work in teams. A small note about C++, we decided in 2018 to remove all C++ from codebase because new joiners on different platforms were always coming with new issues when they were using MSVC or Clang, because they had unions or flexible array members or casts that were refused while GCC accepted them, and at one point we lost so much time that we decided to remove C++ dependencies from our code base. But if you're like C++ only, that's fine. Just make sure that you test for all combination of Clang on Windows, Clang on Mac to not lose time on that. And in terms of organization, so we are an async team, all remote. We do weekly sync for tactical stuff, making sure that people aren't struggling on some things, and making sure that for the next week there aren't a clash of two people working on the same module. And for strategic things like talking about the architecture of our product, we have quarterly in-person meet. So this is 1 week, for example, before FOSDEM. In Brussels, we get the Airbnb 1 week all together, and we do everything that requires a high level of interaction to be productive. And so to go back on the workflow of how we release things, we do PRs against the unstable branch, people reviews. And we also had like every 2 or 3 months some architecture documents or before planning an architecture change. Why? Because as I said, users are really asking for documentations. It also helps editors. This is something very useful for release notes, for onboarding new joiners, and of course yourself 6 months from now, when you have this sprawling peer-to-peer architecture and services, and you're asking yourself, oh, what's happening now? And you forgot. So that's it for Nim in production. With great power comes great responsibility. I'm Mamy Ratsimbazafy, and you can ask me anything. Thank you.